So, we now come to the last part of underwater sensor networks. We will now talk about localization in little bit more detail. We have already spoken about localization and its purpose in the first part of underwater sensor networks. So, what is localization? Once again, so localization is about finding the locations of the different nodes in the network with respect to the known locations of the other nodes in the network. So, there will be some reference nodes whose locations will be known, and trying to locate the other nodes whose locations are not known as a function of the known locations of these nodes. So, so this is how it looks like. So, what we have are these nodes which are acting as the localized nodes. So, these localized node means that these nodes their locations are known, and these are the unlocalized nodes, and there is acoustic mode of communication over here or here or here as well. So, initially what happens is these localized nodes they will be periodically sending out beacon packets, right. So, beacon packets will be sent to advertise their presence, and any node which can hear these beacon packets, they can respond in the form of a request. They can respond in the form of a request they can send. That request will say that so it wants to request the location of it wants to request the location of that particular node. So, so this is an unlocalized node which basically sends that particular request, and then so corresponding to that the response is received and so on. So, why do we need to localize in order to tag? We have already seen this. So, localization is important for a number of reasons. One of the very important ones is that the sensor nodes, for example, these nodes, when they are going to send the data to the surface sink, along with that the location data should also be sent. Otherwise, that data will not be of much value, because the surface sink which has received the data, it will not be able to know that which node from which location has sent that particular data. So, one issue is that localization is a very important problem in any network. Now, for terrestrial networks it is not a big problem, because nowadays we have GPS facility which can help any of the nodes to know the location, the exact geographic location. Exact means with certain error, of course, geographic locations of these different nodes. Now, the problem is that GPS does not work underwater, right. So, it has very low performance or almost no performance underwater. So, in the absence of GPS, how to localize these different nodes, right. So, this is the whole problem of localization. So, there are different challenges of underwater environment and the channel underwater acoustic channels. I am just going to read them once again, because we have already gone through them in different ways in the past. So, so first of all, reference node deployment is a very important issue. Without that, you cannot basically localize any of the other nodes whose positions are not known. Node mobility is a very important challenge and an important issue to take care of. Node density, time synchronization, etc. Now, in terms of the acoustic channel has different characteristics. It has variable sound speed and propagation delay, low bandwidth and bit rate, signal reflection, multipath, fading, etc., high error probability, asymmetric power consumption. These are the different properties of underwater acoustic channel. So, under those basically those challenges, one has to come up with localization schemes. Now, the properties of underwater localization schemes, there are some desirable properties. So, the localization schemes have to be highly accurate. That is quite obvious, because if there is too much of error in the localization of the different nodes, then such a scheme basically which helps to get the the locations of the different nodes, such a scheme will not be very useful. So, high accuracy, fast convergence, that means that very quickly one has to come up with the location of the unknown nodes. So, fast convergence, wide coverage. So, wide coverage I do not need to elaborate further. Low communication cost, also the same thing, and the scalability. So, that means that the nodes, the localization scheme that you propose, if the number of nodes is increased, such a mechanism can be basically extended to the new set of nodes that are deployed. So, so these are the mapping between the underwater environment and underwater acoustic channel characteristics and the desirable properties. So, in underwater sensor networks. So, the localization schemes that have been proposed for underwater environments, they can be broadly classified into three types. Some schemes, they assume the presence of anchors. So, these schemes are called the anchor based schemes. Some schemes basically do not assume the presence of anchors, and these are called the anchor free schemes. The second category is the type of control that is used, whether it is centralized control or distributed control, and the third is range based schemes and range free schemes. So, range based schemes, there are many, and range based schemes are quite popular. So, so in range based schemes, whether you are considering the existence of a reference node or not, there are different schemes that are proposed. So, the first one is the RSSI based scheme, TDOA is the second, and the TOA. RSSI is received signal strength indicator, TDOA is time difference of arrival, and TOA is time of arrival. So, time difference of arrival and time of arrival. So, all of these can help in understanding or localizing different nodes, but in these cases, if you are using these mechanisms, you have to ensure that there are some nodes which you can consider as the reference nodes whose locations are known. So, let us assume that we have a scenario like this, where there is a transmitter and there is a receiver. So, so if there are two signals, a radio signal and a sound signal that are sent, then so what happens is the radio signal will be reaching after a certain duration of time, and similarly for the sound signal, but the sound signal probably will reach after longer duration of time in this particular example. But this just so here we have considered only radio signal, sound signal, where you could have considered maybe two different sound signals and so on, and that is how one can go for using the time difference in arrival between two stations, and using that to compute the location. So, basically so this is the t delay, which is the actual delay, and this is the t delay plus the time difference of arrival, and that time difference of arrival once calculated can help in localizing the different nodes by solving simple equations. So, and without reference nodes also there are a few other mechanisms that are proposed. Location estimation using lateration or trilateration based schemes. So, basically if you know the locations of three nodes, using that basically you can calculate the location of the fourth node and so on. So, and this can be extended further to get more accurate picture and accurately localizing other nodes in the network. Range free schemes, the problem in range based schemes is that the cost of hardware required for range based schemes is not very very useful, right. So, the cost is quite high and it is inappropriate for underwater networks. So, the solution is range free schemes where anchor nodes transmit. Anchor nodes means like the ones where the locations are known. The anchor nodes transmit messages containing the location information and hop count to more than one hop neighbor. The anchor node sends beacon signals of different power levels, and the location area of the nodes are estimated from the reply of the nodes. So, the limitation of these range free schemes are that they provide a coarse estimation of the location of the nodes. So, anchor based schemes basically can be classified into different categories, single stage scheme, multi stage schemes, and single stage can even be further classified into fingerprinting based, range free, range based, multi stage, fixed range based, dynamic range based. So, based on this, you can, as you can see over here, there are large number of different types of there are large number of different types of anchor based schemes which are proposed. So, OLTC is something that was proposed by us, me and my one of my student. 3D UL is also a very important well known scheme, fixed range based scheme that is available in the literature. ALS is another, and so on. So, so a complete picture of the classification can be obtained by reading through this particular journal paper, which is a survey of techniques and challenges in underwater localization, which was published in Oceanic Engineering in 2011. So, mobile anchor based, so those were the stationary anchor based schemes. Here are the mobile anchor based schemes, which can be again classified and subclassified as shown over here. So, again this particular reference gives a good idea about the different protocols and an overview of each of these protocols belonging to these different categories. So, that is localization, and finally mobility. Mobility is very important and it is very interesting in underwater sensor networks. Mobility was also present in terrestrial networks, but that was intentional mobility. So, somehow a particular sensor node, maybe a robot or a human being, would make the mobile node move from one point to another. But in underwater sensor networks, not only that such a intentional mobility can be achieved, maybe using by tying a sensor node with an AUV or a mobile device and so on. By doing that, but also not only active mobility, but also passive mobility, and passive mobility due to maybe the fact that there is some underwater current, or there are different waves and so on which hit these nodes. So, mobility is a very important consideration in the studies of underwater sensor networks, because these nodes are indeed going to be hit by different nodes due to the dynamism of the environment and so on. So, both active mobility and passive mobility are possible in underwater sensor networks. So, the main problem is that when you want to, before you deploy underwater sensor networks, you want to study the behavior by simulating these networks. So, for simulations, as we have seen in a previous lecture, that we need to have mobility models which can mimic the behavior of movement of the different nodes in the ocean column. So, the meandering current mobility model was proposed. So, the meandering current mobility model basically harnesses the idea of how the meanders in rivers move, right. So, so these meanders, how they move. So, basically accordingly, so that kind of model is used accordingly to move the sensor nodes that are deployed in the coastal areas. So, where the or in the shallow water regions. So, in the shallow water regions, basically these nodes which are deployed, they are going to be hit by different kinds of meanders, and how these meanders are going to make these nodes move. So, that basically with that kind of adoption of that kind of model or idea, the meandering current mobility model was proposed. So, meandering current mobility model basically so this is the formula which is basically which basically characterizes the two dimensional flow of a fluid using a stream function like this. So, this is the stream function. So, I am not going to go through this. So, these different parameters are explained over here. So, there are two components of the velocity of the meandering current. One is the u component and the other one is the v component, and these u and v components can be obtained from that psi equation that we have seen in the previous slide. And finally, we come to the oceanic forces mobility model, which was basically proposed by us, by Amit Mandal Mishra, that means myself and two of my other students. And so, here basically what we do is that getting inspired from, or rather taking help of different other forces which realistically occur in a oceanic column, like gravitational force, other frictional force, force due to the rotation of the earth, Coriolis force and so on. We basically come up with this particular model to mimic the mobility of the nodes which are going to float independently in the ocean column. right. So, this is the model. So, I am not going to go through it in detail, but just to show you a picture of how it looks. So, these are the different forces that are acting on a particular node in the ocean column, that is floating in the ocean column, and with the help of that, with the calculation of that, we basically, one can use this particular model to simulate how the nodes are going to move with respect to time. So, this is the Navier-Stokes equation, which if you resolve this, it can give you the x component, y component, and z component of velocity, and these can be used in the for simulating the mobility of these different nodes that we talked about. So, with this we come to an end of the entire 4 lectures on underwater sensor networks. As we have seen that underwater sensor networks, there are large number of different types of issues. So, issues ranging from different things, everything is very chaotic in underwater environments. The environment itself is chaotic, and even the velocity of the sound, and the temperature, the character, the composition of the water, etc., etc. Everything is very different, and it changes spatiotemporally. It changes as we move in the underwater environment. There are lots of different types of noises. There are problems with respect to mobility. There are problems with respect to localization, architecture itself, deployment itself are problems. Plus, additionally, we have the traditional problems of designing MAC protocols and routing protocols for use in these networks. So, it is a very interesting field. So what I attempted to do is to just expose you through these 4 lectures, just to expose you to the different issues of underwater sensor networks. Underwater sensor networks is a field of in-depth study. So, it is not something that can be understood in just a few few lectures, but the whole purpose of introducing or including these lectures in a wireless sensor network course is just to give an exposure of the different issues that are out there. So, those who are interested, I had also mentioned the different references. So, you could go through these different references to know more about underwater sensor networks. Particularly, research scholars might benefit from these references that I had mentioned, and there are lots of research works that are going on underwater sensor networks. There are lots of other opportunities of doing research on underwater sensor networks still remains, and but at the same time, it is a challenging area of research as well. So, with this, I would like to conclude these lectures on underwater sensor networks, and so thank you.